Okay, all right. So you see you guys on sun is on Zoom, and I would like to have your attendance first of all for whole class. Just I want to check. Yeah. So to start with, Samayo, are you here? Samayo, not here. And Triệu嘉明
喺度。
梁志偉，
早晨啊，先生。
技術我技術長李振傑，
喺度。
你同我 here? Not here?
Yes。
吳晶豪，徐家榮，are you here? No? 胡嘉樂，
喺度。
葉斌，曾靜南，呢個陳俊熙，
喺度。
蔡俊明，朱潤輝，魏雲靜。
早晨。
OK，你見我？陸少華，文希，
喺度。
morning，温志偉，
早晨。
余子豪，
早晨。
袁天佑。Okay, who hasn't got your attendance ticket? No. Yeah, we will start. We'll start now. Okay. So to start with, I will give you one file. Sorry. And this is the organic chemistry QA. And it was once used in our pre-SBA section. And today we'll try out some of the questions and try to see if you have done so. So for Chem 2 students, we have finished about 6 questions. And you want to refer to this because why we have spent even an hour to it on those questions. You may find these questions very simple, but if you want to talk into detail for explanation, it will give you some time. So don't worry, I will give you a compilation of those answers for that type of questions. So we will have this, right? From question 1 to question 5, answered in Chem 2. Question 10 also answered in Chem 2. And please refer to the video on YouTube. Now, today, we will go to question 6 for you as a warm-up. Each one of you should have a chance to speak up, or you make use of the chat box to answer, to think of the thoughts. Okay, you get my point? So I start from Triệu嘉Minh. Question 6. The question asks for the chemical test to distinguish between propanol and propanoic acid. So what will we choose?
攞 carbon 嚟試，睇下佢有冇 gas
Hmm? Carbonate. Carbonate. So what chemical exactly you need to use? So remember in your DSC, exact name of chemical.
sodium hydrogen carbonate，跟住 acid 會有 gas，另外嗰個冇咯。
Some sodium hydrogen carbonate like this. So what is the physical state for sodium hydrogen carbonate?
solution
Solution. Can it be solid?
我 solution 就唔使煩佢發生咩事
How solid? How solid? Is it possible?
都得都用啊。
Also okay. So what will be the observation?
Effluence acid 咯。
For effervescence, for acid. How to spell effervescence?
我會寫卡啦啦 bubble
Effervescence. You say that effervescence. Tell me their spelling, please. Suddenly turn to colorless gas bubbles, right? Who else want to copy 21 times? 이상하게
Hi.
spell the word effervescence.
The
21 times.
EFF ER VES CENCE
EFFERV
VES CENCE
VES CENCE.
Yes.
Agree? 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 Do you no need to copy 21 times? But how, what do you think? Is it correct? EFFERVES CNCE, okay? So colorless gas bubbles. How about propane now? How about propane now? How about propane now? No observable change, no bubbles, right? Correct? The whole thing is correct. The whole thing is correct. Go back to the first question. Is solid possible? Solid sodium hydrogen carbonate possible? I add a piece of sodium hydrogen carbonate, solid, into the two samples respectively. One of them they will show effervescence or colorless gas bubbles. We collect propane no exit, and propane now shows no observable change. Is it also possible? No idea, Lin Why? Do you think? Do you think it possible? For solid. Is it possible? No, why not? Is you yes? No. The answer is no. Why not? Why not? Give me the reason. Not AQ, man. It's not logical. My question is, why not solid? Not ionized, not soluble, not dissolved in propanol. What is needed to show acid property of what? Water is needed to show acid property, which means water is acid. No ions in solid state. Sorry for all those points mentioned. It scored no marks in DSE. Samsung.
In solid state, the H atom in acid are not ionized. Therefore, it cannot react with HCl3 in
Yes.
sodium hydrogen carbonate. Therefore, no colorless gas bubbles will be formed.
So the role of water
is to ionize H atoms in acid and to dissolve the sodium hydrogen carbonate.
Yes, that's right. So the indeed, for like one thing's work, the sentence is not so not correct. Hydrogen carbon ions, they are in solid and AQ are also be there. Okay, the question is not referring to mobilize the sodium ion or hydrogen carbonate ion to react. It's okay. Don't get me wrong. Okay, the key point is not on the left hand side. Instead, is on the propane acid itself. Okay. Now, or if you in reality in your chemistry lab, if you are given that two chemicals, propane acid is without water. Okay, even in your in exam, it has been changed to even acid, the one that you may think of vinegar, right? But indeed, vinegar is not equal to even acid. Okay, get my point. While even acid is all equal to vinegar. Why? Do you know why? Because vinegar, it is the diluted even acid solution. While solution here means I add some water into it, and about 6% of it is the ethane acid, while the 90-something% of it is water. So, carbon propane acid, what will be given the reagent bottle, but inside it, no water. So, if no water, without water, for propane acid, what will happen? They will not exhibit. Okay, so the key point is they will not exhibit acid property. Why not? So what Leighton has been suggested, the reason right behind is that with the water, the propane acid will not be ionized to form hydrogen ion. While without hydrogen ion, how come they will react with the hydrogen carbonate ion to form carbon dioxide? So can you get my point? So in the pure ethane acid, because there is no water, so all those they are just molecular form. There will be no hydrogen ion to be present, which will react with the hydrogen carbon ion to form colorless gas. Can you get my point? So the key point, that's why for the marking scheme for this DSC paper, this has been appeared before. That's the then maybe you allow you to answer that like this. First of all, add water to the two chemicals. Second, add sodium hydrogen carbonate. Even though this time I add solid to it, no problem. Okay, because the water has been added and the propanoic acid has been ionized. Some part of it has been ionized to form hydrogen ion. While we have got hydrogen ion, they will react with hydrogen carbonate ion to form CO2. Can you get my point? So the question for that is hydrogen ion react with hydrogen carbonate to form what? CO2 and H2O. So while this one contribute effervescence. So I need the presence of hydrogen ion. Okay? But without water, this one no hydrogen ion. So of course, the key point should be on AQ here. Is that clear? You got what I mean? This is for question 6. Questions? Any doubts? How about question 7? I should invite some people here to answer. Later, why we have 2 accounts? Bugalo. Shall I invite you to answer question 7? Question 7. Chemical test to distinguish between butanoic acid and methyl propanoate. Yeah, I add your chemical formula is not correct. You write the NaCO3 is not correct. Sorry. Yeah, Na2CO3. Yeah, AQ. So what will happen to the 2? Very similar, right? We have got a very similar case as question 6. So you look for what? Yeah. Okay, how about the others? The other one, it will form no observable change, correct? Is that clear? So the one on here is the ester and ethanoic acid. Okay, question 8. Question 8. Let me see, question 8. Who else have an answer? Yabang. Question 8. Propane 1O and propane 2O. How we distinguish them two? Propane 1O and propane 2O. Yabang, are you here? Yabang. Add acidified K2CO7. So what will be the difference in observation? What will be the observation? Hello, Yaban. How about elegant? Trần Tuấn Anh. Trần Tuấn Anh. Or is it you just murmur? Why you say so? So Hex doesn't have all the answer, right? It's not correct. Not possible. What do you think? What do you think? Now, first of all, now I'll give you some hint. Now, orange to green, which one? Now, your button has been saying, right, this part. Which one they will show a color change from orange to green? Yeah, the answer is both. So what is the conclusion? Right, this chemical, potassium dibromate acidified, cannot be used to distinguish between the two. Then warm tolerance reagent. First of all, your tolerance reagent, the spelling of that is not correct. No marks. Secondly, warm tolerance reagent. How about the dichromate? So what will be formed for the propane 1 and propane 2? Now, tolerance reagent is used to test for aldehyde. Which one are you referring to? Propane 1 and propane 2, they are both alcohol. Do you find it difficult now? Do you know why I choose this type of questions to all of you, right? I seldom ask so. Now, you just think of the subsequent chemicals for tolerance reagent, but my question comes, is the series of the chemical test possible? Lucas reagent, yes, that's right. Why? Could you please elaborate more? Now, first of all, for this part, no way. Even though you think of tolerance reagent, no way, because chemical test, remember, it should be somewhat simple, somewhat direct. Okay, so what does it mean by direct or simple? Whenever I add something to it, so what will happen? It will react instantly, and it will help you distinguish which is which. Okay, can you get my point? So this two is not correct. So the question comes, Lucas reagent, and it will show you the three parts. That is the most basic part. What makes the Lucas reagent? The name of reagent, right? What are the chemicals? Two is on the observation, and this is what you have to do. Why? Can you tell me what makes Lucas reagent? What are the chemicals? Yes, indeed. You have to solve it by yourself, right? All of you, while you're waiting, why not? Search in the internet. Do it now. Search on the internet. Tell me what is the Lucas reagent. Instead of just idling, you're sitting here and saying you don't know. You have to solve it. For those who have got the answers, could you please voice out and or maybe you put it into the chat box. Let others know. What is that? Oh, by the way, Samson, your name on it is not in line with the format. What is that, Lucas Rager? Samson, tell me. You're so responsive, huh? You're more responsive than before, right? Tell me, what are the Lucas Rager? Yep,
Zinc chloride in hydrochloric acid.
Yep, zinc chloride in hydrochloric acid, corn HCl, and the observation for both. What are the observation? Propane 1O, propane 2O, what happened to the two? We look for what observation?
佢 react 個速度。
Observation is
observation 係就 white precipitate。
White precipitate. So what is that white precipitate? What is the chemical nature? What is the identity of precipitate? Now go back to the equation. The equation, they are asking for what? You know, what is the equation? What's the type of reaction? The ROH reacts with HCl to form what? It is not zinc chloride will react. It is, yes, it's HCl will react. They will form HCl plus H2O. So which one is YPPT? Which one? RCl. Now the answer is not. Indeed, that two chloropropane, two chloropropane, one chloropropane, they are in liquid state, so it's not a precipitate. But the question comes: is the other three? They are in aqueous. So how about this? How about this? This nature is not miscible with water. So what will happen to it? It seems like whenever it shows that RCl, they will form some tiny oil droplet, which suspend throughout the whole solution. So if I take a look on it from a macroscopic point, I will describe it is not set as white PPT. We'll call it what? Turbid. Turbid. And it is a matter of the speed of the two. That is true, right? So when you compare the speed of the reaction, we have got the following trend. We've got that following order. The tertiary alcohol, it is more reactive than the secondary alcohol, than the primary alcohol. And in terms of having this reaction, so which means that for the same period of time, the more formation of RCl to form, the more instant stability will be formed. So you are going to compare the speed in terms of what? Checking for the increase in turbidity of the solution. So you are going to check it on the web. The mixture becomes turbid for propane 2O in about 5 minutes. How the solution for propane 1O, the mixture, remains clear for the first 5 minutes. So it will tell you the difference in the speed of the two. How about tertiary alcohol? The turbidity show instantly, immediately. Okay, so this is what I would like to draw attention. First of all, Lucas test, Lucas reagent. The chemical to be used is zinc chloride in corn HCl. This time, I would like to use HCl as a reactant to have a substitution reaction. Why we say that substitution? Okay, I remove that hydroxy group, I replace it with what? Cl. Okay, Okay, you get my point. I want to exchange the two. And you are going to look for the formation of the one of the product, RCl. This is liquid, but that is not miscible with water. That cannot be mixed well with water. The reason behind is that structure do not have any parts which form hydrogen bond with water. Okay, something about Michael 2, and you may find that it's set as a not miscible with water. So from a macroscopic point, I know it's turbid. You're checking for the speed in terms of the time for the turbidity to occur. Do you understand? So can you get the way to refine the wordings? Now to start with, it is not by PPT. Second, yes, that's right, you are going to compare the speed. So this is what you have to be aware of. Okay? Hello, are you here? Yep, good. So I would like to pass the time to some other students who hasn't replied anything. Zhu Zhenfei. Please check the try on question 9. Butane 2O and 2-methylpropane 2O. So what is the chemical test? To distinguish butane 2O and 2-methylpropane 2O. Zhu Zhenfei, are you here? So once you know this question, yeah, tell me. It seems that there's a new scenario, right? But you can also play the same tricks. Okay, this time you may use this. Yes, correct. Yes, that's right. Okay. Lê俊傑is also smart, right? He also think of Lucas reagent. Mao Zhujianfei is to distinguish using certified K2CL7. Why is it possible? First of all, for K2CL7, why is it possible? Zhujianfei, K2CR207 certified. So the looking for observation is the 2. What's the difference? Yeah. Secondary can be oxidized while tertiary cannot. Which one is secondary alcohol? Which one is tertiary? Now, this is somewhat we'll talk about the presentation, the means of presentation, the way you present your answer. Now, butane 2O or 2-methylpropane 2O. Yes, that's right. You are going to indicate which is which first of all, before you tell secondary, tertiary, right? Otherwise, the marker will have doubts, and they just give you further questions, further doubts of the marker to think if you really can have a matching of the secondary and tertiary alcohol with the 2 chemical. Okay, yes. So this one that will show you a color change from orange to green. How about this? Tertiary alcohol cannot, which means no observable change. Yes, correct. So some people are too lazy to write this as a structural formula. So what is 2-beta-propane 2 is this, right? It's a tertiary butyl alcohol. Okay, we've got that structure. While butane 2O is just a secondary alcohol, like this. So this part, it can be further oxidized to form butanone, while 2-methylpropane 2 being a tertiary alcohol, that's carbon here, would not have any hydrogen atom directly attached to it. So it can, which means that they cannot be further oxidized by simply losing this hydrogen atom in this carbon. We call this carbon alpha carbon. So if you know more about in tertiary education in terms of chemistry, They will have that technical terms. Okay, it's correct. How about Lucas? Now, Lucas reagent, you look for what? You look for turbidity. Okay, you look for turbidity. Which one will turn solution turbid? Now, this is one. Being the tertiary alcohol, they will turn turbid instantly. What about this one? How about secondary alcohol? They will turn turbid in several minutes, let's say 5 minutes, because of the fact that I just say it in questioning. Okay, it's a matter of speed. Questions? How about 11? Something more challenging to all of you right here. Let's solve it one by one. 余子豪 chemical test to distinguish between ethane amide and ethane amine. Cyrus. Cyrus. Not here. Finish. 袁天佑. What do you think? 袁天佑. Hello, 袁天佑. Act acid with heat. So what will happen? What will happen? What will happen? You acid with heat. So what will happen to the two chemicals? So what does ethane amine and ethane amide? Ethane amine is this structure. Ethane amide, we've got this structure. If you are going to add acid to it, what happened to the two? The question is like this: ammonia gas. Oh, alkaline medium hydroxide ion. Yes, that's right, ladies and gentlemen. First of all, you have to spot it out. It's not acid before you tell this ammonia gas. Which one will show ammonia gas? Which one is shown ammonia gas? Amide show ammonia gas. So can you further furnish your answer? Now, how will you test? How can you sense it? Can you sense the presence of the ammonia gas? Now, hydroxide ion and heat. They will release ammonia. While this one, hydroxide plus heat, so no ammonia, right? But the question comes chemical test, you look for observation as well. So what further work do you need to do? First of all, add a few drops of ammonia solution. It's not ammonia solution, it's hydroxide solution. What I mean is sodium hydroxide, a strong alkaline to it. Sodium hydroxide solution and apply the heat to the two mixture respectively. The observation, they will turn one of them, they will show what? Do you describe the gas? Do you describe the gas? First of all, Chen Long, this double lesson is for Chem 1, and you should go to your another lesson instead. Okay, E3 chemistry lesson is on lesson 2 and 3. I know that you want to stay here, but I don't know whether or not you have got another lesson. Please double check your timetable, Chen Long. You need to be exceed, yeah. Gas with a pungent smell. Yeah. And Van Gaho has elaborated more. If a boy's red litmus paper turns from red to blue, yep, that's right. Good. It's much better, right? It's less subjective, more objective, right? To use some test paper to test over the presence of ammonia, right? So you're going to test the gas, remember? To test the gas with a piece of moist, now this is the keyword, moist red litmus paper. And the gas, they will turn the paper from red to blue. So I know it's ammonia gas, and while the ultimate source of that chemical is from amide. Can you get my point? How about amine? Sorry, no observable change. So you write down no observable change for this. Is that clear? Now, so this is somewhat more challenging. Okay, the same case for question 12. How much time we left is about 10 minutes, right? It seems that this class, Chem 1, is more efficient, right? It seems your class is more efficient than Chem 2 in this topic. Hey, it seems you haven't said anything. That's right. How about bromoethane and aldoethane? How we make a test to show the difference? Hey. Are you here? Hey. Nice. Can you sulfur nitrate? Can you please elaborate more about sulfur nitrate? How? And tell me the principle. You said it as sulfur nitrate. Can you try to elaborate more on the conditions to be used? Solution, you mean? Right? So what are the conditions? I just remember iodine and bromine gives different color with sulfur nitrate solution. Can you twist a little bit? Iodine and bromine, what is that referring to? An element form and compound form? Element form or compound form? You're now referring to iodide and bromide, you mean? But now, if you think of this, the question comes, how can I get bromide and iodide ion from these two chemicals? And that is our concern. Right? Bromoethane we have got the structure. What should I do to release, to make bromo group and iodide group, forming as iodide and bromide respectively? Can you get my point? So in other words, you are going to what? Remove them. How? Remove them and make it iodide and bromide. I need to do some action to it. Yes, that's right. Sodium hydroxide. Good. Can you elaborate more? 梁先為我理陣熱， Could you please elaborate more? So you want to make it the whole steps complete. First of all, you're going to edit the sample, yeah, with sodium hydroxide solution with forming. Okay? So by doing so, these two chemicals will be hydrolyzed. So why I add hydroxide to it, what will happen? The hydroxide will have got an O lone pair, it will go attack the carbon and to make the bromo and the iodide and aldo group, leave it as a bromide and iodide. Okay, so we would tell this type of reaction. What is the type of reaction? A substitution. Yes, that's right. Substitution reaction, a type of hydrolysis reaction. Do you still remember? And what's next? What's next? Once the bromo and aldo group, they will be released as bromide and iodine. You can do the second step. No need to purify, no need to separate. You can do the next step into the solution mixture is by what? Adding what? Silver, what? Yes, silver nitrate. Okay. So because these conditions, we would make that in alkaline medium. Remember to acidify and the chemical with silver nitrate. Otherwise, what will happen? If I do not add hydroxide to it, hydrogen to it, what will happen? Yeah, the observation is different, right? So what is that undesirable observation that will happen? 好交流。好交流。Hi, 好交流。Where are you? How about 黎文靜? If the silver nitrate solution is not acidified, what undesirable observation would occur? Wait, come on, you just claimed that you guys should just claim that you want to have the qualitative analysis experiment, right? So it's somewhat related to this. You should know. 黎文靜, where are you? Or still thinking? 李棠, again. That's you, tell me. Samson. I
可唔可以講多次個問題啊？我聽唔到。
Or you just go away. You just hang it. And the question is, why not acidify silver nitrate solution with X? If without adding X, what will happen? What undesirable observation would occur? This one. Without adding X, what will happen? 係
我淨係知可能會有其他 precipitate form，但我唔知係 form 咩。
3 other precipitate。What's mean by other precipitate? No.
係咪 Ag2O 啊？
Yeah, good. Ag2O. It's in form of a gray PPT that will be formed. Okay, gray PPT will be formed. Can you get my point? So, and this will get mixed with the silver bromide and silver iodide PPT. They will have their own color, and they will overall they will mask your observation. So this is not somewhat undesirable. So Ag2O is from a gray PPT. They will mask the other two color of the PPT form, if that is the case. And then tell me what are the two, if I add acid to it, what acid should be used? What acid? What acid? You use what? What acid should be used? This one. What acid should be used? And second question is asking for the color of PVD of the two. The silver bromide, silver iodide PVD, what is the color? What is the color? Anyone who can help? Yep, dilute HCl. It's not. Dilute HNO3, yes, it's correct. How about the color of PVD? Yeah, yellow. How about iodide? Silver. I did not. Do I need to put off the face mask and give you my facial expression? Maybe from your eyesight you can get what I want to tell you. Quite the opposite. Creamy PVD versus yellow. So this is what I would like to draw attention to it. Okay? Is that clear? So I do hope that you may get to know more about that question. So here comes, I'll just stop at 12 here. 12. Both classes, they will stop at 6 questions. Okay? We will leave you some other questions from 13, 14, 15, 16, 17, 18, 19, 20. Okay, I leave you, go home and try it out. Do we need to spend one more period on that? Do you want to continue or you want to proceed to some other topic? Now remember, for that type of questions, you are going to be very aware of that and you are going to speed up. Okay? You're going to speed up the whole process by thinking all those. All right. Any questions so far? Isn't it?
Hi.
Do you think you can manage finishing the remaining questions before we come?
Okay.
Yeah. Okay. I urge all of you to finish them, and we'll have a more speedy discussion in the next lesson for that. Okay. How about today's? It's a good way for you to record memory, right? Have you learned something new? What things is new to you today? For example, Lucas test, right? Lucas test. This is somewhat new. And second is for question 12, right? You are going to test bromo and aldehyde or maybe halo alkane by simply hydrolyze it. Release the halogen group to form halide ion, and you are going to further test using silver nitrate solution. And what else is about the amine and amide? It's just like question 11. Can you see that? Question 11 asks for on how to distinguish them two, and you are going to check for the functional group. If you use exit, frankly, no observable change will be seen, even though there is a reaction. Okay, just refer to the case of one people suggested that I use exit. Indeed, both will react, but no counter change will be formed, and no obvious other observable change will be formed. But for alkaline, here comes. It's because for amide, as a terminal amide, they will release ammonia gas. And indeed, it is because of an alkaline hydrolysis reaction. Alkaline hydrolysis reaction. They will have that two product, right? And you're going to test one of the product, the gas, ammonia gas, by using moist red litmus paper, and it will turn this color. But not for amine. And this is the principle of this. Last but not least, this is what I would like to draw attention, is for question 8. Just to remember, you use Lucas test to test, but before that, without knowing such, please get noted that what is meant by chemical test. What should be the characteristic? Should be simple, fast, easily observable. So never think of somewhat like doing distillation, doing reflux, and having the chemical and do further action until you can get what you want. And this is not so desirable. Can you get my point? Listen, you just put up a hand. What's the question?
阿 Sir， 點解 tertiary 反而係最快嘅？
Yes, that's right. Now it is shall we spend 2 more minutes before we end up the lecture today? What is that? It's because of the hydrolysis reaction. Now, indeed, that one, they will undergo a type of chemical change. We will call that hydrolysis, and indeed, it is somewhat like this. Now, for example, like this, I would like to compare the two. Sorry, that should be R here. R group, and then R group, and then H, and then OH. And what you are going to do is to add it with HCl, and you know that this chloride ion, they will react, okay, to have got a substitution reaction. To start with, sorry, I put it in the wrong way. To start with, I would like to have it exit to it because it's too strong to leave it. They tend not to leave it. So I would like to have an exit to it to protonate to form water. Having this, they will leave, and they will form R, C, H, and H. That one, carbocation. They will form carbocation. So the similar case for that one, they will show you as a carbocation like this. So the question comes, you are going to compare these two carbocation stability. Which one is more stable? Do you know the answer? The answer is the bottom one. But of course, you may think it is a secondary carbocation, primary carbocation, and tertiary carbocation. They follow such a trend. Why? That temporary species carbocation is rather unstable. How will you make it stable? First of all, why is it unstable? Because the carbon here with a positive charge is easily attacked by some positive charge, negative charge center. Okay, species, then they will react. For example, chloride ion. Right, chloride ion is somewhat negative, right? They would react to it. They will react to it, right? They will heat it. So the best way for the carbocation is to have a surrounding environment and to make it less positive. to make it less positive. How? By having more alkyl group and make it more stable. Why is it alkyl group more stable? Because the alkyl group is electron donating. Why? Please check the ECS, the difference in ECS, and you can go out. I mean, isn't it? Do you understand? Thank you. You exert the effect, and it seems like the electron they are not pushing towards the carbon positive center and make it less positive. So which means that they tend to form this intermediate because it's more stable. So it's a little bit out of service, but that already allows you to understand more about what is the chemistry behind. It is organic chemistry. It is a mechanism. Okay, and you will know it if you get interested in it. It is somewhat about in year 1 in your university level. Okay, is that better? Okay, any more questions? Maybe you need to take a break, right? You need to take a break now. So see you guys. Bye bye.